Hey Year 12, I hope everyone is okay. Today we are going to look at heart rate regulation, and then next week we'll tie it all together, and then I get to finally see you again in person. So today's title please is heart rate regulation, and we are going to work through this, some new information as we've already built on some stuff we've looked at GCSE level, so we're now going to build on again and see how we get on today. So, heart rate regulation. So, even though the heart is myogenic, okay, and will always keep beating, as we've looked at already, we do have a change that we can make in the heart to increase it or decrease it using our ANS, our autonomic nervous system. Okay, so during this time of the ANS, we can rise the heart rate or we can reduce the heart rate by thinking about it using our brain. Now then, the way this does this is with increasing it through the SA node or decreasing it through the SA node. So obviously if the SA node starts to beat faster, the whole heart will, because it's got the start of a firing pin, and then vice versa, if we decrease that for whatever situation, that will then decrease and the SA node will react further. So the way in which this works is something, obviously as I've said, the ANS, and then we link this to the cardiac control center. So the cardiac control center receives information from the medulla oblongata. Okay, hopefully we've all seen Waterboy, and we know about our medulla oblongata. And what it does, it receives information from all the sensory systems or some sensory systems around the body, and these take in charge of your heart rate. And what we're going to look at now is the three key areas you need to know of which feed back to the central or the cardiac control center, the CCC. So you can kind of imagine the CCC as the boss, and what it's doing is having all its little work people tell it how it's functioning in different areas around the body, and then it then reports to kind of the head boss, okay, which is the SA node, changing and decreasing or increasing that heart rate. So we're going to look at what nervous systems feed the cardiac control center. So what we're looking at here in detail is the individual parts that we need to know. So the ANS is the regulation of the heart rate, and it is controlled and firing the SA node. And then, as I said, we have the cardiac control center receiving information from the sensory nerves and sending direction to the motor neuron to change the heart rate. This is obviously found in the medulla oblongata. So as I said a moment ago, we're going to look at the cardiac control center and what the three main areas that we need to know are. So we have, very first of all, our neural control. Now this is broken down into three separate areas. Now these three separate areas do different things, but they all link to our neural control system. So the first thing we have is our chemoreceptors. Our chemoreceptors are located in the muscles, the aorta, and the arteries, and they notice chemical changes. So when we look at chemical changes, we look at our CO2 level, our lactic acid thresholds, okay, and all of these things will then feed back to say if they've been increased, oh, we need to increase the heart rate now. Oh, okay, we're going to do that by our CCC, and the SA node is now going to increase because we need to get rid of this lactic acid and this CO2 level build up so that we can function correctly. We then have what's called our proprioceptors, okay, so our proprioceptors, and these detect motor activity. Okay, so the fact that your muscles, your tendons, joints, ligaments are all working and moving maybe more than normal would indicate you're doing activity. So again, we'd have an increase feeding back through the CCC. Finally, for our neural control, we have our baroreceptors. Okay, now these detect the increase in blood pressure. So these are found in the blood vessel walls, okay? So that increase in the arterial pressure will then obviously mean that we're having to go under some strain for whatever reason that might be. So think about weight training, okay? We have strain onto the blood vessel walls because we're lifting heavier types of things. Therefore, we are going to increase that heart rate, okay? So we're then going to be using the ANS system, and we're then going to be looking at increasing the firing rate of the SA node. So that's the first three under neural. We're now going to look at our intrinsic control. So the intrinsic control center is broken down into two sections. The first section is it identifies temperature change. Okay, and this then obviously has an impact on the viscosity. So we talk about that being thickness of the blood, because if you have less water because the temperature is too hot in your blood, which is made up of the plasma setup being mainly water, okay, you're then going to have not such great speed of contractions and the nerve impulse transmission is going to be slower. Okay, so it's going to make you more lethargic, as we know from our hypothermia and hypothermia. We then look at our venous return. Okay, this here is the return of the blood to the heart. So this has a direct impact on the stretch of the ventricle walls. So if the ventricle walls can't push that blood back from our lower leg because you're using valves and using their movement control with our muscles and the ventricle walls themselves, this then is going to have an effect on the amount of blood that comes back to the heart, and therefore the amount that can be pumped out from the stroke volume, and also the power of the contractions that come out of the ventricular contractions. So ventricular contractions, taking it through the pulmonary artery to get oxygenated blood from the lungs, and also through the aorta to feed outside of the body, hence why it would have an impact on our stroke volume as well. So we're finally going to look at my hormonal control under the CCC. So this here is specifically looking at adrenaline and noradrenaline, okay, which is released from our adrenal glands, and this increases the force of the ventricular contractions, okay. So therefore this is going to increase the stroke volume and obviously therefore the cardiac output, and increases the electrical activity through the heart. So there's going to be more beats happening and more power coming through because of that adrenaline rush that comes through there. So now we need to look at what and how it happens. Does the heart rate increase or does the heart rate decrease? So we are going to now look at what does this. So as I said, we're now going to look at this. We've now had our three areas that our CCC gets information from and then can control, but now we need to know what the decision is from the CCC to send to the SA node. Now then, we have our sympathetic nervous system, or SNS, which will directly increase the heart rate. So when the CCC turns around to it, it will go, oh, okay, we need to increase from the information we've been given. Or, oh no, we need to use the parasympathetic nervous system, which will reduce this, okay? Now, these are broken down into two areas. So the sympathetic nervous system will obviously accelerate and push the SA node to contract more, okay? However, the parasympathetic nerve, okay, inhibits this, and it then has an effect on our vagus nerve, lowering the heart rate, okay? So new word there is obviously our vagus nerve, which is just an area that's going to reduce our heart rate and kind of steady it down, slow those impulses. So the pathway looks like this. We have our CCC, which is obviously gathering all that information from our chemo, our propro-baro, temperature change, venous return setup, and our hormonal change with our adrenaline or noradrenaline. We then have a decision that's made as part of our ANS and the control center. This is then going to increase or it's going to decrease. And how does that happen? It happens from our accelerator nerve or our vagus nerve, and that all feeds into the SA node. Can you please get this written down as kind of a flow diagram, and then we will be able to have a go. Okay, what I'd like you now to do is to use your book to go over the areas that we have just looked at, so page 36 to 37, and what I would like you to do is to fill out the factors affecting the CCC and give me a brief overview about what each thing is, and also what it does and how it's an effect on the heart. So obviously if there is going to be more carbon dioxide because we're looking at our chemoreceptor, we would need to increase that heart rate. But obviously adrenaline, we'd want to do something different. So have a think and see if it goes up, goes down, and briefly explain what each one is. Okay, hopefully that's taught you some different things today, team, and you've been able to have a chance to look over the book just to clarify anything you didn't understand. Obviously, if there is things you don't understand, please do let me know on Teams. And I'd like you to submit a photo of this long answer question. Obviously, this long answer question is only worth 4 marks, but I really want to see how we've gained all 4 marks. I also would like to see 2 distinct colours, please. So 2 distinct colours in there. What I mean by that is 1 colour of you doing this from memory without looking at your book or the textbook. And then the second part of this to go back and correct. I want you to correct the literacy. I want you to correct the spelling. I want you to correct the actual content and make sure that this flows really nicely to gain yourself 4 marks. Okay, write out the question in full. And then send me a picture on Satchel 1 of this completed. Year 12, I am really excited to be welcoming you back, obviously on the Tuesday, ready to go on the Wednesday, Thursday, Friday. So if you have any issues, do also let me know there. If not, team, have a great lesson and thank you very much.